Hi boys and girls, I'm glad you could join me again today. Today we're going to talk about two more of the body systems, the respiratory and the circulatory system. But before we begin, we need to talk about some important vocabulary words. The first one you've probably heard before, and that's lungs. Lungs are the main organs of your respiratory system, and you have two. We're also going to be addressing capillaries, and those are tiny blood vessels. You really can't see them through your skin. They're so tiny. They're inside your body, but you can't see them outside. Another one later on in the lesson is heart. That's the muscle that pumps blood through the blood vessels to all parts of your body. It does this automatically, 24/7, 365 days a year. You better hope so. We have arteries, which is the blood that leaves the heart through these vessels. It leaves through the arteries to go into your body. And then we have veins. Those are larger blood vessels, and they return the blood to your heart. And you'll see later in the lesson when I show you my heart model exactly how that pathway happens. All right, so those are some important words we'll be talking about as we discuss the respiratory and then later the circulatory system. Today we're going to do about 3 activities with the respiratory system. So stay with me. I'm trying to be entertaining, but have to be informative too. I don't want to just do experiments and you don't know why I did them or what they mean. All right, addressing the respiratory system first. Your body cells need oxygen to work. When you breathe in, you take in oxygen that your cells need. When you breathe out, you're getting rid of carbon dioxide. Remember, the chemical notation for that is capital C, capital O2, CO2. That means carbon dioxide. The cells give off that, and plants like that. The main organs of the respiratory system are, like we said, the lungs. The lungs are about in here. They're surrounding your heart. The air enters your body through your nose and mouth. It goes down your trachea, which is in your throat, to your lungs. As you breathe in, your chest gets bigger, and your lungs fill with air. It's good to take deep breaths like that a lot throughout the day. Your trachea divides to form a system of tubes in your lungs. They look like a tree. The branches continue out until they get smaller and smaller, and then they end in tiny little air sacs. All around these are tiny blood vessels called capillaries. The walls of the air sacs and capillaries are very thin. The oxygen passes through these walls, moving from the air sacs into the blood in the capillaries. CO2, carbon dioxide, passes the opposite way from blood in the capillaries into the air sacs. So it's going back and forth the whole time. So what are the main organs of the respiratory system? If you said lungs, then you're correct. Now, we're going to go ahead and do an activity that has to do with the respiratory system before we talk about the circulatory system. Okay, the first investigation we're going to do is quite simple, and it doesn't take many parts. It just takes you and some kind of a timer or a stopwatch. I bought this at a teacher supply, but I think that you could use your own stopwatch or even your stopwatch on your cell phone. All right, once again, your breathing rate when you're active is different from the rate when you're sitting quietly. It may change when you walk across the room or down the street. In this investigation, we're going to measure your breathing rate after performing 3 different activities. Once again, the material, stopwatch, or timer, and of course you. The first thing we'll do is make a chart like this. In the packet or the attachments that are in the description on YouTube is a chart like this. We'll put the activity, the first one sitting quietly, where they count the number of breaths that you take, that you exhale out. And then we'll do after marching in place 1 minute, the number of breaths you exhale out. And then after running in place 1 minute, the number of breaths you breathe out. Of course, we can take a rest in between there as needed. While we're sitting, we're going to count the number of times you breathe out in 1 minute and record that number on the chart. So it'll be something like this. You probably won't have too many in a minute. Okay? Okay, now that you recorded how many times you breathed out or exhaled from just sitting quietly, let's try the next one, which is to stand up and march in place. Now, raise your knees as high as you can when you march in place. You'll start the timer. This timer doesn't have batteries, so I can't really start the timer. I'm just going to kind of count in my head. So go ahead and stand up and march in place for a minute. Okay, so you can do this on your own later. So let's say that the minute's over. You should be a little bit less, you should be a little bit breathless. Not quite, but maybe a little bit. And now you'll record the number of times you exhaled after you did your marching in place for 1 minute. And you'll notice even after that, if maybe the number of breaths you exhaled, the second activity were more than the first. All right, the last activity you'll be, after you've rested a few minutes, that's why I'm not going to do this on the video. After you've rested for a few minutes, then you'll run in place for 1 minute. And when running in place, you don't need to run around the room. You just run in place for a minute, and then as soon as you stop running, start to count the breaths that you exhale or breathe out and record that on your chart. Okay, so after you've done all that, then we're going to look at the drawing conclusions and think about which activity needed the fewest breaths. What that means each time that you breathed out. Which needed the most. You can probably make a prediction in your head which way you think it's going to go. What can you infer, or what can you assume, reasonably think that this probably happened about breathing from what we did in this investigation? Now, scientists usually measure more than once. What could you do to be sure your breathing rate measurements were correct? I'm thinking if you said try this whole thing again, once, maybe twice, maybe 3 more times, although you're not a scientist, so you don't need to do that if you don't want to. But that would be a more accurate count to tell if sitting quietly or running in place uses the most breaths. Okay, this time we're going to need a little bit more materials. And as you can see, I've got them already here. What we're going to need is a gallon jug, water, plastic straw, a dishpan or a bucket, a measuring cup, and then 18 to 24 inches of rubber tubing. I didn't really measure this, but somewhere in between there will be fine. Okay, and what we're going to do is find out how much air can your lungs hold, or in this case mine, because I'm going to demonstrate it for you. Remembering that oxygen from the fresh air goes into the blood in the tiny air sacs named alveoli in your lungs. And then carbon dioxide is given off and exhaled from the lungs. Okay? So each time we inhale or breathe in, our lungs will fill with air. So the first thing I'll do is I'll get those things ready, and then I'm going to go ahead and inhale, so I'll have a lot more to exhale. Okay, so we're going to get the gallon jug and fill it to the very top. I don't want any oxygen to be hanging around up there, so I need that to be completely full. Then I'm going to fill my dishpan about 1/4 full. This might be a little bit more, but basically it has to be able to cover the entire top of the gallon lid. Okay? Okay, so I filled my gallon jug all the way to the top. I'm going to hold my hand over there so no oxygen gets in before I touch the water. And then it's heavy, so you have to really hold on there. Now, with your other hand, you'll try to slip a little bit of this tubing inside the gallon jug. Not so easy to do, but you can do it. It doesn't have to go way inside there, just enough so we're going to get the air that my lungs breathed out into the jug. Okay? And then we have to hold it while we do that. All right? Not easy. Okay, so I'm going to breathe in first. Okay, now I need to take a breath, so that means I'm done. Now I want to hold up the jug again, and you'll see that quite a bit of water is missing. I'm going to put a piece of tape where it ended at the top. Okay, so when I measure, I'll know exactly how much. Now I'm going to move this. I don't need this anymore. And what I'm going to do is fill my measuring cup with water until it fills the rest of this jug up, and then I'll measure in the measuring cup how much water or oxygen took the place of water. Okay, because I don't have a sink out here in my studio lab, I'm going to use the water from the jug or from the dish pan. Okay, that's 2 cups. And put down something on your table when you do this so you don't get water everywhere. That's 2 cups, which is equivalent to 500 milliliters. And here's another 2 cups, so now I've got 1,000 milliliters. And I'm spilling some, so it's not going to be completely accurate. Quite a bit of oxygen I breathed in there so far. That's 3 or 6 cups, which is equivalent to 1,500 milliliters. There's 8 cups. This measuring cup holds 2 cups each time. Just about. Here will be, I think maybe 1 more cup. Okay, so very close to 10 cups. And with each cup is worth 500 milliliters, so a half a liter. So probably, I would say, doing the math real quick, 4 liters, something like that. Okay, and this is all wet, so we want to move that out of the way. So what I would say on the second page, the last page of the experiment, or the activity, is that my lung capacity is somewhere in the neighborhood of 6 liters, maybe something like that. And then my conclusions are, what are some factors that might affect the lung capacity? Do you think that non-smokers have a larger lung capacity than smokers do? Think about what smoke does to your lungs, and you can probably answer that question. I Googled it, and it said your normal average lung capacity is 6 liters. So I guess I'm a little bit lower than average, but I'm a lot older than you. So yours should be good. You should probably almost come up with an empty gallon of just nothing but air when you come up from the pan of water. Okay, so I hope you enjoyed that. We've got 1 more coming up, and it's time. Okay, the next one, I'm not going to do this with you, but I'm going to go ahead and explain how to so you can do it yourself. It might be a little while before you can do it, because what you need is an empty dish detergent bottle. As you can see that I just purchased this one, and it's not empty, so I don't have anything to use to show you. I used another empty one I had. What you'll need is some tape, a small round balloon, and a large round balloon. And what you'll do is have your parents' X-Acto knife, or you can use some kind of scissors, and cut out the bottom. So for this, you would cut like this, cut out the bottom. All right? And then on the bottom, you'll take the large balloon, you put it inside this way, and then you'll reach around, and so you've got the lip. Actually, this one didn't even have a lip because you have to cut it. So you'll cut it about here, and you won't have this little hole where you usually blow into. So it's a lot easier to stretch it and to work it around so it's sticking out like this. Then you put tape on here to hold it on. Then you'll do the same thing with the top portion, except this one you'll put the small balloon inside, as you can see, inside the detergent bottle, and then carefully stretch the little opening before you try this, and then you put it around the top of the detergent bottle. This whole thing is in the packet that you either already received if you're a subscriber and I have your email address, or you can download it from the attachment on YouTube. Then you'll put tape around that as well. Now what this demonstrates is when you're breathing in, your diaphragm goes down. Okay, when you're breathing in, your diaphragm goes down, and then it makes your lungs, and you have to see real close. There's just, your lungs are just sitting there. Then when you breathe in, your diaphragm goes down, and your lungs fill up with air. This would probably be a better model if it was bigger, so hopefully yours will be bigger, and you can pull on it harder, okay? So what happens is they fill with air, and then to do the gas exchange, the lungs serve several other purposes. They also help clean the blood of blood clots, and fat globules. The lungs also cause air to move past the vocal cords that's able for you to speak and use other vocalized sounds. All right, let's draw some conclusions on that. I know you haven't done it yet, and you really didn't see me do much with it. Once you've done your own, what happened to the lung balloon when the diaphragm balloon was pulled down? Did the top one, the green one in this case, did it fill up with air? Probably not as dramatic as if it would if you have a bigger balloon in a bigger container, but yes, it did. What do you think would happen if the diaphragm muscle in your chest were paralyzed? If it wasn't able to go down, would you be able to put air in your lungs? I don't think so. That's a conclusion we could reasonably draw. Okay, I hope you get to try this at home on your own. It'll be a little bit more easier for you to see what's going on when you do it yourself. Okay, I'm back. I don't know if you missed me, but here I am. Okay, now we're going to talk about the circulatory system. Your circulatory system includes your heart, all of your blood vessels, the tubes that blood flows through. The job of the circulation system is to take blood to all of your body cells. The heart is the muscle that pumps blood through blood vessels to all parts of your body. It's only as big as your fist. So if you have a small fist, that's as big as your heart is now. Not to say it can't grow as you get bigger. It's very strong and it works all the time. It only rests between beats. Blood leaves the heart through blood vessels called arteries. Arteries branch out to all parts of your body. They become really small until they're tiny capillaries. Okay, the capillaries carry blood to every cell in your body. Then the oxygen passes from the blood into the cells. Carbon dioxide passes from the cells into the blood. After the blood flows through the capillaries, it enters the veins. And you can see your veins on your wrist if you look. I was looking just the other day, and the only ones you can really see are the blue ones. Those are the veins that haven't been oxygenated yet. Those are the only ones you can see. Doesn't mean the other ones aren't in there. The veins, which are the large blood vessels, return the blood to your heart. Which part of the circulatory system pumps blood to all body parts? Think about it. Okay. Here's how your heart and lungs work together. The heart and lungs work together to bring oxygen into your body and take away the carbon dioxide. Each time you breathe in, the blood in your lungs gets fresh oxygen, and it says, yay! This blood then travels to the heart, which pumps it to the other parts of the body, and I'm going to show you with my heart model in just a moment. The heart has 4 sections called chambers, each acting like a pump. The chambers keep the blood that enters the heart from mixing with blood that leaves the heart. You don't want that to happen. The chambers are connected by openings, each covered with a valve that opens in only one direction. It closes when the chamber is full. And believe me, there are people as they get older that have issues, and maybe when they're born, where they have to have surgery to fix this, because it doesn't work properly. What makes the blood follow a one-way path through the heart? In one moment, I'll show you a little bit of the path of the heart through my heart model. Okay, this heart model shows how the blood goes around and picks up oxygen and then goes to do its route, one-way path, and then it comes back after it's been oxygenated so it can give oxygen to all the cells. in your body. You have to, if you had a heart model like this, it's not very expensive, but not everybody has these hanging around their houses. You have to go slow. Your own blood path through your heart and lungs is all the time and not very slow. Depends on your conditions. But as a child, for most of you who are watching this, you're probably about 8, 9, or 10 years old. You're just doing fine, and you don't have to worry about it. You don't have to take any medications, so it'll go do its one-way path the correct way. And you can see that as it fills up, it has to start doing its route, its one-way route, okay? The left side here, that's where the oxygen-rich blood from the lungs is going to enter the left side of the heart into the chamber called the left atrium. Okay, on the right side, the oxygen-poor blood, and it doesn't have enough oxygen in it, is returning from your body to go get more oxygen. So it's a pretty nifty little system we have going on all the time, 24/7, 7 days a week, 365 days a year, for how many ever years you live, and I hope you live to be 100 at least. So that's a long time for your heart to do this all the time. It only gets to rest between beats. Now, if you're lucky enough, like I am, to have a stethoscope, and I'm going to move my heart model for just a moment, you can listen to the beat of your heart. It gets pretty loud in your ears, so you might want to put some stuff in your ears that doesn't hurt you. Okay? Then what you do is you put this part, the round part, on your heart. It might take you a second to find where you can hear it. Oh my, I don't have a heartbeat. Uh-oh. I better keep going until I can find one. There it is. Boom, 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 boom. That's not much of rest. They're lucky they get a second rest every 5 seconds. So think about how hard your heart, which is a muscle, works all the time. And it never lets you down until it does. But it won't, so don't worry about it. Okay? So if you're lucky, like I said, to get a stethoscope, which is what the doctor uses to make sure that your heart is beating properly and there's no issues to worry about, and they'll listen in the back to your lungs and make sure they're clear. It's kind of a fun thing to have, and they're only about $7 at a teacher supply, or if you can go to a learning supply like Lakeshore. Well, there's a plug for them, but okay. Now, what I did here, and after we do the summary, I'll explain what I did, so all the human body systems will be in a little, I don't know, kind of a graphic organizer, kind of a notebook way, so that you can remember all these things in a fun way. But I'll show you that in a moment. All right, let's go ahead and summarize what we did today. Oh, by the way, I got red dye, which is what's used in this heart model, all over my white tablecloth, and I don't think it's going to come out. So don't do your mom's white tablecloth. Don't use that. Go to lots and lots of old towels or paper towels when you're putting the mix in your heart model, if you have one. Okay, let's summarize today. Lungs are the organs the body uses to breathe. Breathing trades CO2 or carbon dioxide, which is a waste that cells give off, for oxygen, which cells need, so they like oxygen. They don't like carbon dioxide. Blood carries gases to and from cells through the blood vessels, the capillaries, the veins, and the arteries. The heart pumps blood through the body. The blood contains red blood cells, which pick up oxygen in your lungs and deliver to your cells. Your heart has been pushing your blood around your whole life. Your heart sends blood around your body 3 times, all the way through your body, 3 times every minute. That's over 4,000 times per day. 4,000 times per day times 7, 28,000 times a week, 28,000 times 365. I don't have my calculator. Whatever that is, that's a lot. Every year. Your whole life. That's a lot. Okay? So be good to your heart. And when I say that, I mean exercise. Make sure you're exercising your heart and your lungs, which is a good thing for you to do the cardio. And don't eat too many things that are not good for your heart. And I think if you can think about it, you know what kind of things those are. I think if you have a choice between broccoli and a cupcake, think about your heart. Pick the cupcake. Just kidding. Pick the broccoli. Okay? Now, what I've been talking about on your graphic organizer, I made this little book out of 3 pages of, or 3 sheets of construction paper, human body systems. I wrote skeletal and muscular, which we did last week. Put some white paper in there and make the notes that you can get from your pages if you download from the YouTube, or if I sent them to you. And then today, the respiratory and the circulatory system, just the key points. You don't have to know all the details. And then next week, we'll do the nervous system and the digestive system. It's just a handy way to keep all your body systems and the notes. You know, just for maybe you might do this in your own science class later in the year or next year, and you'll have something to kind of go by, so you'll remember some of these things. All right, that's just an idea I have. You don't have to do that, of course. Now, at the end of the packet that I've sent to some people, and the others will have to go on YouTube and on the attachment, there's some little fun sheets and some worksheets about the heart, and a little word puzzle, and some other sheets about the respiratory system and the heart, the circulatory system. Just some fun things to do. Once again, you have no place to send it. I'm not going to grade it. You don't have to do it. But it might be kind of fun to do. So that's it for today. So I'm hoping that you'll come back next week and watch me, every Friday at 2 p.m. or anytime after. And like I said, next week we'll finish up the human body system. And, we'll talk about those last two systems. And what I want to remind you is my email, in case you want to, I have it here somewhere. Oh, here it is. My email is sciencegranny, all small letters, 50 @gmail.com. sciencegranny50 @gmail.com. Email me. I want to see who's watching me and who's learning some things, and maybe you can give me some ideas, tips, comments, anything. I'll take anything. I know you have an email account, so use it and write to me, okay? I think that's it for today. I'm looking around, make sure I didn't forget anything. If you have a magnifying glass, look at your veins. They're kind of cool. You can't see them moving, though, but they are at the speed of light, just about. I mean, it goes around your body 3 times in a minute. That's a lot. That's fast. Faster than a car on a freeway, I would think. All right, that's all we're going to do today. So I'd like to remind you just one thing. Keep doing science, and don't forget to be awesome. Bye.